Okay, these are our notes for section 3.1 on solving systems of equations, and there's three different ways to solve a system of equations. You can graph it, use substitution, or elimination. Now these notes are just on graphing. Your other videos will be on the other two methods, but these notes we're just going to focus on graphing. First thing we need is a definition for a system of equations, and what a system of equations is two or more equations with the same variables. Alright, we are going to focus on two in this video, but we could have more. We could have three equations with three variables or four equations with four variables. What we're going to focus on are two equations with two variables that are the same in each. So both of our equations should have an x and a y, or an a and a b, or a d and an e, something like that, but they need to have the same variables. Now, there are two different ways we can classify our answers to these. Now, you're going to get an answer for each system by graphing it today, and you're going to have to classify it also. And the first way to classify them is either consistent or inconsistent. Consistent means it has at least one solution. So it has to have one, or it could have more. It could have three, it could have five, it could have infinitely many, but it has to have at least one. Inconsistent means there is no solution to our problem. Okay? Consistent then can be broken down into two more categories. You could have what's called independent, which means it has only one solution, or dependent, which means it has many solutions. Okay? So we could have consistent independent, which means there's only one solution to our problem. Consistent dependent, which means there are many solutions to our problem. Or inconsistent, which means there's no solution to our problem. Now we're going to be using graphs today. So when we graph these out, if it's going to be consistent independent, that means there's a point of intersection. Okay, those two lines are going to meet at some point. Consistent dependent means that there are many points of intersection, and inconsistent would mean there are no points of intersection. Okay, so keep that in mind as we're going to graph these. We are going to do our first example here. And our system of equations is 2x plus y equals 5 and x minus y equals 1. Notice we have two equations, two variables, and the variables are the same in both equations. Now what we need to do is get those into slope-intercept form so that we can graph them. Okay, slope-intercept form, so then we'll plot our intercept and count our slope out. This first one here, all we need to do is subtract 2x from both sides. So we get y equals negative 2x plus 5. This was our original. 2x plus y equals 5 minus 2x from both sides. And we get our new equation, and we're going to plot that. Our intercept is 5, so we're going to go up to 5 on the y-axis. 1, 2, 3, 4, 5, and put a point. And then our slope is negative 2, so we're going to go down 2. That's really negative 2 over 1 to the right 1. We're going to do that again. 1, 2 over 1. Let's do it one more time. 1, 2 over 1. We want to make sure we have enough points to make a good line. And then we're going to connect those. And there's our first line. Now we're going to do the same thing for the second one. I'm going to rewrite that down here. X minus y equals 1. We've got to get it in slope-intercept form. So subtract x from both sides. Negative y equals negative x plus 1. Now we can't have a negative y, so we divide everything by negative 1. It's going to change all our signs. Y equals x minus 1. So our intercept is negative 1. Put a point. And our slope, what's in front of the x there, is really a 1. It's 1 over 1, so we go up and then to the right 1. Up and to the right. Up and to the right. Connect them. And we're going to look where our 2 points meet. Notice there is 1 point of intersection. And if we go up to our classifications, 1 point of intersection, we said that's consistent. Because it has at least one solution, and then independent, because it has only one. And the answer to that problem is 2, 1. That's where the point of intersection is. And that's how we solve these types of problems. We get them to slope-intercept form, graph them, look and see how we would classify them, and then if there is an answer, we give the answer. Got a pause and practice problem for you here. It is 2y equals 6 minus x, and 6y equals 12 minus 3x. Pause it, work it out, and then unpause it and see if you got the right answer. Alright, now that you have worked it out, let's solve it together. Let's start with this first one. 2y equals 6 minus x. Let's get it by itself. Y by itself in slope-intercept form. So we're going to divide everything by 2. That gives us y equals 3 minus, there's really a 1 in front of that x, so it's 1/2 x. Now that's still not in slope-intercept form, we got to switch it around. Y equals negative 1/2 x plus 3. Now it's in slope-intercept form. Well, there's our intercept, 3. So we're going to plot that point. And then we need to go down 1 over 2. Down 1 over 2. Let's do one more. We'll put 4 points on there. Alright, there's our first line. Let's do the second one. It is 6y equals 12 minus 3x. Divide everything by 6. Y equals 2 minus 1/2 x. Flip it around. Y equals negative 1/2 x plus 2. Notice they have the same slope. Both of them have a slope of negative 1/2. That should tell you something about your lines. Okay, your intercept is 2. We're going to go down 1 over 2, down 1 over 2, down 1 over 2. Connect them to make a line. What do you notice about those two lines? Well, they are parallel lines. And that's what happens when your slope is the same. You get parallel lines. Those lines never intersect. Okay, so there's no point of intersection, which means we would classify them as inconsistent. Okay, and those are your notes on graphing systems of equations.